In this tutorial, we're going to perform a dynamic analysis on the same truss structure from the previous video. The truss will be loaded for a very short time duration, and we'll study the transient behavior of the structure. We're going to use Abacus Explicit for this procedure. The truss structure is fixed at one end with pin joints, which means it cannot move in the x or y direction. However, it is free to rotate about the z-axis. A concentrated force of 600 newtons is applied at one of the nodes for 0.01 seconds. We are going to use the dimensions from this schematic. We will use SI units where length is in meters. The radius of the truss members is 1 centimeter or 0.01 meters. The truss is made of steel with a density of 7.8 grams per centimeter cubed, a Young's modulus of 200 gigapascals, and a Poisson's ratio of 0.3. In a static analysis, the inertial forces have little impact on the overall response of the structure. The standard general analysis performed in the previous tutorial did not include inertial effects. However, in a dynamic system, we know that the inertial effects will have a significant contribution to the structural response. We need to tell Abacus to capture these inertial effects. We do this using a dynamic analysis step. This can be achieved in Abacus Standard by specifying an implicit dynamic procedure, or in Abacus Explicit by specifying an explicit dynamic procedure. We're going to use Abacus Explicit as it's generally the best choice for problems with short dynamic response times or problems in which you are interested in the transient behavior.